Let's examine this absolute value problem. So we want to solve for the value of x. That would make this statement true. Well, let's review a little bit about what we know about absolute value problems. So we know that if I have an absolute value, I can have some number in there that might be negative, could be a negative number, or the number inside could be a positive number. And in either case, we're going to get a positive number for the answer. Well, why is that? Because absolute value is the measure of distance from a given point. And the measure of distance is always positive. Okay, so looking up here, I know that my absolute value inside, I'm going to rewrite the problem, 2x minus 1 equals 5, that this could be absolute value of 5 could equal 5, or the absolute value of negative 5 could equal 5. So notice how what's inside can be a positive number, or what's inside could be a negative number. Okay, so there's a couple ways that you can choose to solve this. So let's look here. 2x minus 1, it could be the positive number 5, because the absolute value of 5 equals 5, or it could be what's inside could be the negative 5, because negative 5 absolute value equals 5. Okay, so case 1, case 2. So let's go ahead and work that out using those two cases. So that means I'm going to write case 1, and I'm going to write case 2. And what I want you to think about for case 1 is the absolute value of 5 equals 5. We agree with that. And for case 2, the absolute value of negative 5 equals 5. You agree with that. So notice that this is inside the absolute value and this is inside the absolute value. So that means case 1 is going to be, I'm going to take what's inside the absolute value, 2x minus 1, and that's going to equal 5, because that was the value I said equaled 5 straight up. In this case, I'm going to take what I have inside the absolute value here, 2x minus 1, and I'm going to make that equal to what I have inside the absolute value here, which is negative 5. So those are my two cases. So now I've gotten rid of my absolute value sign, and I can just go ahead and solve for x. Now let's take a little commercial break about solving. So what I want to think about when we're solving a problem is we usually think about PEMDAS. Okay, so PEMDAS is order of operations, parentheses, exponents, multiplication or division, whichever comes first, addition or subtraction, whichever comes first, as you're working the problem from left to right. Well, we talk about it going this way when we're simplifying the problem. But I want you to think of using PEMDAS this way when you're solving for something. So we're going to think of doing PEMDAS backwards when we're solving. Are we solving? Yes, we're solving for x. So we're going to do PEMDAS backwards. So let's look at case 1 and let's think about PEMDAS. So I want to get x by itself. So what's happening to the x? Well, it's being multiplied by 2 and it's having a 1 subtracted from it. So I think of doing PEMDAS backwards. I look, is anything being added or subtracted to my x? Well, yes, that 1 right there. So I'm going to unsubtract it. So I'm going to add 1 to both sides. So then that gives me 2x equals 6. Well, I don't have anything more that's being added or subtracted, but I have something that's being multiplied. I'm here now. That would be the 2 times x. So I unmultiply it. So that's going to give me, I divide both sides by 2, I unmultiply. That gives me x equals 3. So that's one possible answer. Now we have to do the same thing with case 2. So the same sort of thing is going on. So I'm going to add 1 to both sides. I get 2x equals negative 4. And I have to divide by 2. So I get x is equal to negative 2. That's my other answer. Okay. So we have to make sure that our answers are in fact valid, because sometimes when we solve absolute value problems, we can get what's called an extraneous answer. So we have to ask ourselves, is there anything that's extraneous? Question mark. Now, extraneous means an answer that's lying. So we have to see if one of these is lying. So we're going to go ahead and put our answers back into the original problem. So let's do that. So here I have the absolute value of 2 times 3 minus 1 equals 5. And over here I would have the absolute value of 2 times negative 2 minus 1 equals 5. So I'm going to have to simplify the left side. So now we're talking about simplifying. So when I simplify, I'm going to do PEMDAS from left to right. Well, you could say you don't have parentheses, but you do have what's inside the absolute value. Okay? So you have to do what's being multiplied first. So that's the absolute value of 6 minus 1 equals 5, which gives me 6 minus 1, which is 5. So 5 does equal 5. The absolute value of 5 does equal 5. So that one's good. Now we're going to do this one. The absolute value of 2 times negative 2 is negative 4 minus 1, which equals 5. Negative 4 minus 1 is negative 5, and that's still in the absolute value. Okay? The absolute value is a function that's being performed on whatever is inside of it. So what's the absolute value of negative 5? Well, it's 5. So both of those answers work. Now this also asks you to graph. Well, there's two ways that we can graph this function. I'm going to show you one way right here. Using my ruler, I'm going to draw a number line. And so this is how I draw number lines. I don't bother putting all the little marks. I just need to know I have 3 and I have negative 2. Well, negative 2 is over here and 3 is over here on a number line. If I want, I could put 0 here. Not necessary, but you can do it. Now, because this is an equality, it means it's exactly negative 2 and it's exactly 3. So those are the two answers of x that solve this problem.